looking here at section 1.3, which is now combining our A, B, H, and K all together. So let's start by looking at combining stretches. So that means your A and your B. So, does the order matter? We would say in this one, no. It does not matter if you do A first or B first, because they're multiplying and dividing. So in BEDMAS, it doesn't matter if you multiply first or divide first. So that's why it's no. Reflections and translations. That means having an A and B that are negative, and then including that with an H and a K. So here, the order does matter. And so we'd say that your A and B must be done first. Then we're going to look to the vertical and horizontal translations. That's H and K. H and K can be done in any order. So does the order matter? We're going to say no. That's because H and K are adding and subtracting. And again, in BEDMAS, the adding and subtracting, the order does not matter. So the only thing that matters is that your A and your B have to come before your H and your K. So it does have to be following BEDMAS. You're multiplying and dividing before you're adding and subtracting. So please copy this down into your notes. And if there's something you need to memorize, again, make sure you understand your A, B, H, and K. Let's go then to our first example. This one we're going to transform y equals 3f of 2x, showing each step. So let's apply the a value of 3 first. What should the a value of 3 do to my graph? So the 3 is going to make things 3 times taller. So the green graph here represents the 3 times taller. Now the b value is dividing by 2. So now I'm going to take my x values and divide them by 2, or cut them in half. And then that would be the resulting graph. Oops, I missed that one. That would be the resulting graph of 3f of 2x. So that's applying the multiplying by 3, and then applying the divide by 2 on the x-axis. Now before we do our next example, I just want to draw your attention to something here. The b and the x minus h. In order for the h to be performed properly, the b has to be factored out of the x minus h. So you'll notice here that the b is outside of these brackets with the x minus h. If you ever notice that b is still inside the brackets, you'll have to divide it out before calculating your h value. So that will have a difference on your h value. So let's look at our next example, which is doing exactly that. Here your b value is inside your bracket. So before we can calculate this, we're going to remove the b value from the bracket by dividing it out. When I divide the 3 out of the 3x, I'm just left with x. When I divide the 6 by the 3, I get a plus 2. So notice how dividing my 3 out of the brackets changes my h value. That is the proper form it needs to be in order for the h to work properly. Alright, so we have b is 3, h is negative 2. We're going to start by applying b, because b has to come before h. So I'm going to start by dividing my x values by 3. So this 1 is going to become a third, this 4 is going to become 1.3, and this 9 is going to become 3. So that would be my graph with the b value of 3. But now we have to apply the h value. So the h value is negative 2, which means every point is now going to move 2 to the left. So we'll take each one of these points that we found and move them 2 to the left. So it's going to look something like this when your b and your h have been applied. Here in example 1, we're starting with an original function that is x squared, and then we're going to apply the transformations as shown in this transformation notation and create our new function. So first, we should be thinking about what the function x squared looks like. Maybe it's easiest to draw a table of values. And if I make a table of values, it'd be negative 2, negative 1, 0, 1, and 2. And then since the function is x squared, I would square my x's to get my y's. So minus 2 squared is 4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So my original parabola would look, mine's a little bit off on here, something like that. So then we can figure out our A, B, H, and K and plug this into mapping notation. So mapping notation is going to be x divided by b, which is 2, plus h, which is 4, a, which is negative 1/2 times y, plus k, which is 1. So mapping notation, we plug our a, b, h, and k into our mapping. Now when I want to see where these midpoints end up, I'm going to actually pick the points on my original function. So what's the easiest point on our original function here? 0, 0. So let's put 0, 0 into the mapping notation. So I'm going to put in 0, 0. We get 0 over 2 plus 4, negative 1/2 times 0 plus 1. So when I add 0 to 4, I get 4, and negative 1/2 times 0 plus 1 is going to be 1. So my vertex, when I plug in 0, 0 to mapping, is going to end up at the point 4 and 1. Alright, so then our final point should be 2 and 4, changing to 5 and negative 1. Now we're going to attempt to graph this. So your graph will look something like this. So here in example 2, we are saying that the red graph is our original graph, and the blue graph is our new graph. We need to figure out A, B, H, and K on how my red graph became my blue graph. So let's start with A and B, because A and B have to happen before H and K. So when I look at A is talking about how tall your graph is. So this graph is 1, 2, 3, 4 units tall. My blue graph is 1, 2, 3, 4, 5, 6, 7, 8 units tall. So how did I go from 4 to stretch it to 8? 2, right. So we're going to say that here A equals 2, because I multiplied the 4 by 2 to get to 8. Now let's try the same process with B. So I'm going to check how wide this one is. 1, 2, 3, 4, 5, 6, 7, 8. But this one is only 2 wide. So what did I divide by? Remember, B is dividing. What did I divide by to go from 8 to 2? 4, yep. So we're going to say my B value is 4. Now the H and the K should be easier. But you do have to think about your invariant point. The invariant points are the easiest points. So if I look at this point at 0, 0, that point is invariant because it was not affected by your stretch A of 2 or your stretch B of 4. That point didn't move. So that's easier for me because now I can just count from that vertex to the new vertex. And that should be my H and my K. So I'm going to count H, 1, 2, 3, 4, 5, 6, 7. So it looks like H has been moved left 7. And then K has been moved up 2. So when we plug in your A, B, H, and K into your formula, it will look something like this. Now let's take the next few minutes. We'll work on these textbook questions, 4, 6, 7, 9, and 10. Again, trying at least 2 from each question.